Okay, welcome back, ladies and gentlemen. They're going to take a look at our review test for part 2 of logs. So let's get things going. So rewriting the logarithmic equation in exponential form, these are super fast and super easy. We are taking the base of our log, 5. You are raising it to whatever that equals, because the answer is always your exponent. So 5 to the third equals 125, and you're done. Okay? So for all of these, what I'm doing, so here, 1, 2, 3, 4, 5, okay. We got 10 or 100,000 raised to the 0 power equals 1. Cool, done. You've got 2 raised to the negative 5th power equals 1 over 32. Done. You've got 64 raised to the 1/2 power equals 8. Done. Okay, 1/3 raised to the negative 2 power, okay, equals 9. Good. Okay, done. And then finally, 4 to the 2nd power equals 16. Done. Okay. So you're just rewriting it. Now, if I'm going the other way, so rewriting the exponential equation in logarithmic form, okay, the answer is always your exponent, so equals 2. That's the base, log base 7, 49 equals 2. And it's just, again, a pattern that you're following. So the answer, so it equals 5, that's my exponent. Log base 10 is just log, and then you're looking at 100,000 right there. Okay? If you're wondering why I didn't put 10 here, because technically the 10 exists there without having to write it. Let's see here, equals negative 4, log 1/2 base and 16. Okay, log base 9 of 1 over 729 equals negative 3. And finally, log base 2401 7 equals 1/4. Oops, I'm sorry, my bad. Okay, easy stuff. That's like the gimmies right now. Now, expanding and condensing, you guys have to know that multiplication is broken up with plus signs, addition, division is broken up by minus sign, subtraction, and the exponents get pulled out front. So when it said expand, log base 3, 9x to the 6 over y, we've got log base 3, 9, plus sign, okay. Now the exponent for the x is 6, so 6 log base 3x. And then because I'm dividing, it's just minus log base 3y. Now, you could be good there. I will let you guys know log base 3, 9 can be simplified down more. What I mean by that is 3 raised to what power gives you 9? Hopefully you guys are cool with the fact that that's 2. Right? I will accept either of these. Okay, I really will. Alright, just so you know. Okay, so if it's just numbers here, you always see if you can break it down. Sometimes you can, sometimes you can't. Condensing, we're combining everything together. Okay, so when it says log 12, okay, there's my 12. Now let's see here. I've got plus sign means times. Because there's a 3 out front, that's the exponent. So it's 2 to the third. And then minus sign means divide. And then that 4 is out front, that's the exponent of 5. Okay, so I've got 2 to the third, this one I'm going to use a calculator for, which is, oops, alright, I'm just going to put everything right in here, 12 times 2 to the third, that's not 12 times 2 to the third, 96, okay, and then 5 to the fourth is 625, 96 divided by 625, I just don't know if I can reduce that down, I cannot, okay. So it's just log 96 over 625, done. You always look to see if you can reduce it down, and there's no 10 raised and nothing can give me that, so we're good there. Well, not a whole number anyway. Finally, this was a challenge one I threw on here just to kind of push you guys a little bit. Look up top, 12x to the 5th, y to the 3rd, z to the 11th. On the bottom, w to the 4th, q squared. So I've got natural log of 12 plus 5 is my exponent, 5 natural log x plus 3 natural log y plus 11 natural log z. Okay, those were all up top, so they were all plus signs. On the bottom, minus, my exponent for w is 4 natural log w. And because q is also on the bottom, you could put a minus there. 2 natural log q. Guys, there's two ways to write this. I just wanted to show you real quick. Probably the top one is the one that probably makes the most sense. You could also have done this. I know somebody asked me about this the other day. If you want, since both w and the q are on the bottom, I can do this. Okay? Because they're multiplied together. Just make sure you put parentheses around it then, because they're both in the denominator. Either one's fine. If you'll notice, all I did here was distribute the negative sign. It's up to you. You're totally your call. Alright. Alright. So the heavy hitters now at the end. Either or. Okay. So for number 1, solve each equation. Round answers to the nearest thousandths. Okay. So 16x raised to the x plus 3 equals 64x minus 2. I need to get the same base here. So for 16 and 64, I can do 4 squared to get 16, but I still have the x plus 3 up top. And I can do 4 to the third to get x minus 2. You could also have done 2 raised to the 4th and 2 raised to the 6th, I believe, and you'd still get the same thing. Okay. Since it's the same base, all I do now is to make them the same. So 2 parentheses x plus 3 equals 3 parentheses x minus 2. Distribute 2x plus 6 equals 3x minus 6. Subtract 2x. Add 6. 12 equals x, or x equals 12. Okay, cool. So, pretty simple. Okay. Hardest part is just make sure you try to find what number can be raised to this power. So, you get the idea. Here, take note, natural log of 3x plus 6 minus natural log of 4x minus 8 equals 0. I'm going to add natural log of 4x minus 8 to the other side. Because now I have a natural log of something equals natural log of something, and I can just make these equal to one another. 3x plus 6 equals 4x minus 8. Subtract the 3x over, add the 8 over, x equals 14. Okay? And then we're solid. We're good. Now the only thing we have to double check for sometimes, if I plug this back in, I need to make sure that this value for a log or a natural log is positive. If I put 14 back into both these, they would be in fact positive, so we're okay. 3 is super easy, but don't forget to divide the 6 over first, or whatever number is out front. If you do not, this will be wrong, okay? So I've got log base 4, 3x minus 2 equals 2, and now you rewrite it in exponential form. What does that mean? It's the thing you did up here. 5 to the third equals 125. 4 to the second equals this junk. Okay. This is 16. Add 2 over. X equals 6. We're all good. Okay. So it's an easy problem, but you've got to divide by that number first. If you don't, you're wrong. Okay. Like there's no ifs, ands, or buts about it. Okay. Now, here, you're going to notice that this one equals 0. Super easy. This one equals 6. Not so much. So, log base 2, I'm going to condense these. 3x times x plus 1 equals 6. Okay? So now I'm going to rewrite it in exponential form. 2 to the 6th equals 3x squared plus 3x. I just distributed that. 2 to the 6th, bear with me here. 64. Okay. So if I subtract that over, okay, there we go. Alright. Now, from here, you would normally want to factor this. Okay. Okay. So, you would want to factor that do the first times the last. However, as I'm just realizing this now, this is not factorable. Okay, so please make a little note here. We'll be able to factor one test. But for the sake of showing you how this works, I'm going to do quadratic formula. Okay, ABC. So we're looking at, let's see here, -3 plus or minus square root 3 squared minus 4 times 3 times -64. All of that divided by 2 times 3. Okay, now under my square root, my discriminant, we're looking at 3 squared minus 4 times 3 times -64. 777. So, -3 plus or minus square root of 777 over 6. Alright, now, here's what I need you guys to take consideration. Again, you will have one's factorable, so you can get two nice numbers. If I do -3 plus square root of 777 divided by 6, I'm going to get an answer of 4 point, now if we're going to the nearest thousandths, that would be 3 decimal places, so 4.146. And if I did that with minus -5.146. Okay. If you put this should be down here. If you put 4.146 into x for this problem, you will get a positive value both here and here, and that's fine. If you put -5.146 in there, you're going to get some bad news because you can't have a negative. Because again, 2 raised to what power can give you a negative value? Nothing. So you're going to have to cross that off, and you're going to have to write down extraneous. An extraneous solution we talked about in class is one that works when you solve it, but if you plug it back in the original problem, it doesn't work in the original context. Okay? So that's your entire test in a nutshell. Please feel free to ask questions. As always, keep up the good work, and good luck. We're all counting on you.